go live because this discussion is important.
Okay, good.
Okay.
And I'll repeat what I said when you go live.
We are live.
Okay, today we're dealing with a question in classification where sometimes we want to treat missing values as another category. Sometimes we will use a method, a classification method, modeling method, to replace those missing values with predicted values, or we call that imputation. But we were also talking about the thing that makes classification a bit harder than regression is, for example, with regression, we know we always care about R squared, or that R squared is always a good metric. But in classification, by the way, that's how well the accuracy with which the predictions match the actual data that we're trying to predict. But in classification, and in sometimes multi-classification, where we don't just have a positive and negative case, we have multiple, 3 or more classes. We can't always say that we care about F1 score. A lot of people get focused on F1 score, and that doesn't necessarily tell you the whole story. Accuracy in classification problems is important, but if your model is working with a poor data set, and it's, over time, you're going to have to get a better quality data set to get better accuracy, it could be that you need to focus really strong on recall. Now let's remember what recall is. And we showed some images last week for that, both from the really highly used, I'm sure, Wikipedia page for confusion matrices, but recall is just the total number of predictions we got correct for either positive or negative over the total number of cases for that, like negative, true negatives, or true positives. So it's basically what we got right over the total cases that should have been predicted that way. Whereas accuracy considers both sides. It's saying, what was the accuracy for all of the cases? In other words, the ones we got right over all the cases. And but again, yeah. Oh, I was just going to finish up. Let me say one final statement. Again, sometimes we care about overall accuracy, but sometimes, let's say it's a sentiment analysis, and it's just, there's just 3 classes. There's negative, neutral, and positive. Well, the company that you're doing this work for, they may want to go do their best to address the negative comments with someone. So they really just want really good negative sentiment accuracy. Well, that would be the negative recall. And that would be an example of what we're talking about here. But there's a lot of metrics associated with classification that you can go look at. What were you going to say, Guy?
I will start from the main difference between classification and regression. I will abstract it very much. Hopefully it will not be bad analogy to use, but it's something I found it in our life. Even regression in life, it's there, it exists. We only need to explore it. But classification, we create it. Okay. Now, without humanity, there is no classes in the world. Now back again to the machine learning. Regression tasks, it's why we always care about the R square, because we want to be sure how much we are accurate in our regression task. So perfect, R square, it's giving us, we can use the adjusted one, but at the end, it's giving us this. Classification, it's task, manufactured task at the end. It's following really the business needs. It's following even some kind of very customized needs most of the time. How much, even if it's standard process or standardized process, but at the end, it's a human performance here that create these classes. According to that, sometimes we know that our data is not enough to give us accuracy 100%. Sure, we will never reach accuracy 100%. Okay, now here, let's start from the binary case. What is the most important for us to be sure about? If it's, for example, let's give a small example. The rapid tests for COVID, this small tools that used at home for testing COVID. It's here in Europe, it's very famous. It's very common to use it. Whenever there is a business case here, you have two classes. It's not machine learning task, but you have two classes. Either you are negative toward COVID or positive. The manual telling you that if it's negative, then we are sure that you are negative. But if it's positive, go and make PCR. You might not be positive. This is classification. And what is the most important? It's to be sure that you are 100%. If you are negative toward COVID, that means you are really safe right now. Now, this is, we will face it maybe in all classification tasks. So where to go? First of all, understanding what is the task that we have and what is the most important. According to that, we can choose what is the confusion matrix that will help us. So yes, most of the time, maybe we are more focusing on positive recall or negative recall more than accuracy, unless the task it's not critical and the accuracy it's very high. That means we are talking about 99% accuracy. So this is the first. So accuracy, that's why it's not playing major role in the models. Most of the time in the research, they are focusing on the accuracy because it's something fancy. Most of the time you can, at the end in binary classification, maybe for sure you are guaranteed that you have 50% accuracy, and then you can discuss about what's more. So this is the first. The second, it's so that's why accuracy, it's not the major player in the confusion metrics. Now, F1 score, it has a specific importance. I will speak about it later, but why we are always focusing in area under the curve? Because also it's not about how the model is performing good, it's about how the methodology followed can be performing in good way. That means it's giving you better understanding about this modeling process that you followed, but not sure that your model, it will be great. This model, maybe you have to do something to make it great, but the methodology, it's working. So that's why AUC always important. Now, as I mentioned, according to the task, we can go for the recall, positive or negative recall, sensitivity or specificity or whatever you can name it. Now, why F1 is important? This is what we have to mention. F1, it's showing how much it's harmonized toward the two classes, your data set it is. So that's why F1 is important, because you know that it's your model is working correct, let's say in performing great toward the classes that you have, all of them. So mainly F1, this is the target. And here again, the importance of F1 is related also to the business task itself. So that's why F1 sometimes it's important, because you want your model to be sensitive toward all the classes on a very harmonic in the same power, let's name it. My last point about all of this right now, and then we'll see the discussion where it will go. It's about the missing values. It's about the different classes. Here, it's controlled on how the model is fit into the overall application. Sometimes the application didn't give a chance for outliers. For example, if we are checking if this picture is dog or cat, and there is no chance to have a bird image. So maybe we don't need to think about the third class. We have to focus on cat and dogs only. This will be easier, and it's controlled by the process, not by the model itself. But here we have to know the model limitation. That means we have to mention it clearly and document it, that this is limit for this task in this scenario. But sometimes, no, the model has to perform in general way and has to know at least if the sample that we have, it didn't belong to the classes that we are trying to identify. There is a final class, which is it's not applied or not part of our experiment somehow. And here also we have to add some samples related to that. So all of this, it's considered. The missing values, most of the time also it's used as a specific category, just to keep it a separated class, and then it will be tested by the business experts to tell that if this missing values, it's really we can keep it as it is, or we have a specific scenario to deal with it. Especially, for example, in my work, which is related to the healthcare, we are not make the imputation that much. We very, very sensitive toward imputation because we want to be sure what to input really. So this is my comments about what you mentioned. I hope it's helpful. I hope it's also can bring more questions.
And I hope the images that I was sharing while you were talking were helpful to those listening, because they're just images we've been using to help people understand, but understand. And by the way, a lot of time you got to be careful. Some confusion matrices are oriented with the actual values over the top and the predicted values for the rows. And that's the way I'm used to seeing it. But sometimes it's the other way around, like here. But when you go to this famous wiki page, which I put the URL in our chat, by the way, if you just type in confusion matrix wiki on a web search, you will most assuredly get this wiki page at Wikipedia at the very top level. But it's instructed that only these 4 cells are the confusion matrix. But you can see so many other metrics can be derived from this. And I think what Guyth and I would both like to encourage you to see is that just because a metric you see someone else using doesn't occur in here, doesn't mean it's not a good metric. That's the thing. It's like Guyth said, we see regression in nature all the time. Classification is a human creation. And because it's a human creation, we have created these metrics that aren't necessarily as intuitive as the metrics we can see with our mind's eye on regression. For example, when you look at what R squared, how it's really calculated, when you see how it relates to correlation strength between 2 variables, it becomes very instructive that you see that intuitively, whereas this is the kind of stuff you have to think about a little more. And again, this is what you see reported in a confusion matrix, but from this, we can calculate so many more things. For example, Guyth was talking about F1 score. Well, all of those are based on what we were seeing. And by the way, all of these are rates. We don't typically think of them as rates, and we drop that term, but this is a true positive rate. This is a false negative rate. Well, why is it important to do that? We use the harmonic mean when we're dealing with rates. And F1 score is truly the harmonic mean of recall and precision. Well, recall really has to do with the accuracy of a given class prediction. Precision, that just is how tightly clustered it is. I'm not going to say I don't like F1 score. It's not one of the things I really care about. Whereas accuracy, let me make this as big as I can. And this is going to get a little fuzzy, but accuracy to me, what we got right over all cases. Well, then now that's important. Now, what we could say here instead of positives, because I should have called this positive recall, what positives or what class predictions did we get right over all actual correct classifications for that? And that can be the positive and negative for each of those classifications. But so, oh shoot. So we don't get that too confused. Please remember, when we have multiple classification, it doesn't need to be complicated. This is the true positive. And then these would be, see, again, I've got it actual classes on top just to show you, and predicted on the rows. So it's different from the Wikipedia. But that would mean that these are the true negatives. In other words, a hot dog, but all of these are not hot dogs right here. And here we had actual hot dogs, but we predicted Coke or Fritos. So use these colors to correlate those. And then we get our false positives, which are here, and our false negatives, which are here. So I showed this so people don't get easily confused when we talk about multi-class classification. And again, remember, there's a recall for both negatives and positives. So for each class, so in a multi-class, so here you could say, well, I care about the negatives. Well, then make this true negative, and this false positive. You just invert these letters here for that case. And finally, to show you one other thing. Oh no, let's see. I want to show you this in a more focused way. So I'll get rid of this one. When you relate this back to null and alternative hypotheses and statistics. So again, statistics, a human creation, and thankfully so. When we look at this, the line going right here would be our significance value for a test. And here, when we look at confusion matrices, classification problems, at least for 2 class, we're doing this. Now, we could do this for 3 or more classes, but it would be harder to view these then. But what's important here, if you've heard of sampling power, well, this whole area from this point over under this alternate hypothesis curve, that's your sampling power under here. And then, so these would be our false negatives, meaning we're saying, yeah, because we set our significance value here, we ended up classifying these as the null hypothesis when they should have been the alternate hypothesis. So that is a false negative. And then over here, though, we were truly still, because of the overlap, we were truly still the null hypothesis, but we said it was a false positive. It ended up being a false positive, meaning it was rejected as the null hypothesis when it shouldn't have been. Now, how do you learn all of this language and setting up hypothesis testing carefully? My favorite way to encourage people to go do that is from Sol Khan Academy, either their probability and statistics course or AP statistics course. Really great lecture material. And then as you go through all that material, create a cheat sheet as you go so you can see the whole lay of the land. But
so
I fill in.
Just I'm here. Yes, I'm here. I'm just want to maybe let's back to that yes, to this chart. Here, when we talk about the false negative, and mainly for the false negative, which is we have it it's clearly show what is the significance level that we are looking for, and how when we change it toward our task that we are looking for, how the results might be changed. But here it's important to back again and let's say double click on the false negative and false positive. Why in the recall we are using the false negative, and in the precision we are using the false positives. So mainly what we are looking for is the ratio of true positive toward in the recall toward all what is really it's positive. That means that something it's positive, but falsely we are decide it's negative, which is not correct. So that's why the positive cases over the all actual positive. In the precision, we are looking for the positive cases toward the all predicted positives. So this is just, I want this to make it clear. So the precision is showing us our, let's say, our model performance toward the samples that we have. The recall, it's let's say it's showing our model performance toward the actual word that we are looking for, or our data test set. So this is the major change difference between recall and precision. And from this, you can discover a lot of changes over. That mean when you are calculating the sensitivity and specificity, sometimes sensitivity and specificity, it will be a must to find it, which is at the end you can the model, it's the modeling process, it will find it, but it will be the real evaluation matrix for you, because it speak the mind of your business somehow. So it's more understandable than recall, which is the same somehow, but yes, they use to like the sensitivity toward a class. Let's say sensitivity of your model toward a specific class. So this is what I want to add here.
Guys, should we then let's talk about so we've been let's let's review what we're talking about at a high level and why. Understanding metrics for classification can be a little daunting, is what we're saying. It can be difficult, but if you take it step by step and really think it through, like in this pseudo math way, it's very helpful. But we haven't talked about perhaps an undisputable, very important metric in this realm of classification, which is, Guy, the ROC or AUC curves, correct?
Yep.
And just to illustrate real quick, here's a video I created from Animated Images, just to show, well, how do you create an ROC curve? It's by taking that significance level and sweeping it across your two cases. Now, I'm doing a very strange example here, but keep this in your mind's eye. We're sweeping from left to right on the significance level between null and hypothesis, but look how it draws the ROC curve backwards. Well, that's instructive, but let's look at some other cases real quick, and then we'll...
Tom.
Yes.
Sorry to interrupt, but when we're looking at the ROC curve, I've always been taught that it's the look at the line that reaches the top the fastest. So I'm a bit confused why the animation is going from top to bottom.
It's probably because of the order in which I'm drawing it. This might help more. This just shows how the ROC curve changes for both sweeps in the mean. So right here, let me wait until it starts over. In this first case, they're right on top of each other, and as they separate, you get this more what we would call approaching a perfect case. Whereas when you have them already somewhat separated and you just tighten the standard deviation, you can get the same effect. And by the way, that can occur with just more sampling to get that tighter sample standard distribution. Now, Jonathan, I don't know if that helps. So what I'm going to do is close this one and go back to the first one, which was here. So I'm bringing it back for you, Jonathan. If that, what I just showed didn't answer the question, let me know. It could be that you were taught, well, you sweep from right to left. I'm just sweeping from left to right. And yeah, maybe I drew this backwards.
The other one was better actually, where it just expands was
Yes.
showed up for me anyway.
Yeah, this is to just show the dynamic of how each ROC curve is created. That second video I showed was actually the case where, after we draw, it's drawn a complete sweep for each of these many cases that it's showing as the mean moves, and then as the means are stable, but the standard deviations go down. So we would, in other words, to create all of these curves that are shown, we would have had to do a sweep on each of these individual frames of this. So
here is sorry for interruption. Here is the question. I think it will make a difference a lot. I think now when we have the AUC, it's almost next to 0.5, for example, and our data assets, it's really reflecting the population actually, which is it's accurate, not biased, everything. What that mean?
Oh,
the AUC, it's 0.5, for example.
Right. Oh,
and we have perfect data set used.
Yes. So I think you're asking that to the class, not to me, correct?
I'm asking to yes, to discuss about it. That yes, for sure. Jonathan, maybe he is the best.
Well, and I gave it away by one of the frames in one of those videos, but yeah, Jonathan, do you know? And it's we're putting y'all on the spot, so no.
Sorry, what I was busy eating at the same time there. Sorry.
No worries.
Okay. The question was, when we have the AUC, it's 0.5, and we have a perfect data set used. That means there is no statistical issues, there is no PS, nothing there, no missing values. And then the AUC is 0.5. What this means?
Ooh, what does it mean?
Yep.
Everything is equal.
And according to that, okay, continue. Okay.
So it's the case when the ROC is along that diagonal line, maybe it's just barely above it. It means that the model is really not any better than just using the average. We might as well just predict using the average.
This is what I'm looking for. That's all. And I know you will answer it, Tom. I'm sorry, but this is why the importance. What is the importance of the AUC? It will give you a real understanding about what your model, and according to that, the methodology you followed, what it will give you.
Now, this video is a B. It could have been 100%. If I had done this, I should have showed sampling power reducing as significance level increases, the sampling power decreases. In other words, the smaller the area of beta, the stronger the sampling power. But then you're sacrificing your, it's a trade-off between the amount of false negatives and the amount of false positives. So, but depending on the realm you're working in and what this is predicting, it could be that you want a lower alpha and a smaller beta, or you want or the inverse. But let's look at the video that helps us see what Guy was pointing out, because this is really, it's really important to boil this down to what we call the pseudo map. And guess who wants outside? Talk, guys, while I let the monster out.
See, just I want to comment about this, about alpha and beta. Yes, this is what I tried to explain in the beginning. When you are really interested about the true negative more or the true positive, for sure it's better. The better scenario that you have everything is 100% accurate, but this is classification task. That means always there is something more important for the business that you are serving. So yes, this let's say how to say it in English, balancing between alpha and beta, it will be always there. So mastering this, how to create the samples that help you to increase alpha or beta, it's also a key in classification tasks.
So this
Yep.
video shows the answer to Guy's question perfectly. Now, here comes the beginning. Right now. Okay, see how they're overlapped? Now, as
Yep.
as the overlap goes away, the ROC curve improves. And when it's, okay, here it grows out, but then when they're separate and they just have, it's already has some value better than average on when they're not starting out overlapped, but we just improve the standard deviation. In other words, we make the standard deviation smaller.
Yep.
That's when we start, well, we at least start out with some good predictive ability. We only improve it as we tighten the standard distributions. So there's those two dynamics. We either have an overlap and we never look at an ROC curve. Well, we could. It would have been funny, Guy. We could have made the ROC curve go below the line, right? And then the predictions would be worse than average. But that
Yep.
would mean that when we start out in this overlap condition right there, it means we would have moved to the left and the ROC curve would have been worse than the average. So this vertical line is saying that's a prediction based on the average. False positive rate versus true positive rate, they're exactly equal for all cases. But we can get a state where the prediction is worse than average. You can get R-squared scores that are less than 0 too. That means the predictive line you came up with in a regression problem is worse than the average, using the average. But you don't want to get those. But I've actually had models with poor hyperparameters that went negative on R-squared, and to improve it, you only had to adjust the hyperparameters. But I think y'all get the picture. This stuff's valuable for the sense of just getting a feel, a better feel for what all this means. So don't leave it in your mind's eye as just trying to memorize these things. Get to this pseudo math level. Try to envision or even do it yourself. And I can share my code with you to do these animations. How do we get the, how do we, through code, using fake data, or even using real world data, come up with a real ROC curve? Now, let's remember, these are beautiful continuous curves. Why do I do that? Because I'm an artist by heart also. But in reality, this could have been ugly bends that were approximately normal and they were approximately symmetric, but they were just two histograms overlapping. Then we would have a really choppy looking ROC curve as we swept from left to right or right to left, as Jonathan would prefer. And I don't blame him for preferring that, because it does mess with your mind to see that ROC curve drawn backwards for sure. But I hope this is helping you guys. And then there was one other video, I think. Let's see if I can find it for y'all. It is instructive. There we go. No, I should. Oh, okay. Let's say we're keeping I'm just moving the average of the alternative hypothesis. But what I should have also shown, again, this is a B video. It would have been great if I'd have showed sampling power at the same time, right? But truly, this is there's the lowest sampling power, and here is the highest sampling power. Yeah. So now that back on Linux, and I could have done it on Windows, but I'm using ImageMagick and FFmpeg to very automatically create these videos when I do them. It's much better now. But this is a friend on LinkedIn had posed this question in one of the comments of a post I did on this particular video. And okay, let's pause for questions, because what good is your modeling if you don't have a metric by which to compare different algorithms, different approaches? That's what we're getting at here today. And getting this level of understanding, the way we've worded this here and here, but really not just for that, but for all these possible, let me so y'all can see more of this stuff. Look at all these possibilities here. Wouldn't it be great? And I plan to do this, but I wanted to make where my ultimate goal for these dynamic things I've been doing is to create a graphical GUI where you change the you change some of these percentages, like you change these values, like we've been doing in the videos that use these things, and you see how it affects all these metrics, but all the pseudo math is there. There's little sliders to control the amount of overlap, and then you can switch from looking at these beautiful continuous curves to increasingly ugly random sampled histograms and creating the same thing. So that's where this is going long term, but it's been, we can't put videos in the book, so I can't do too many of those. That's the main priority right now. But if you go through this and really try to feel about the importance of each of these and think about how would I describe that with pseudo math? That's when you're really getting a deeper understanding. And yet, let me repeat what I said earlier. Please don't be afraid to create your own new metric, but be prepared to explain it and why you felt it was important to use it. Because again, we're almost obeying nature completely when we come up with a metric for regression. But classification, like I said, such a human creation. Yes, humans created these. Yes, humans created R squared, but R squared was like observing nature. This was that we have so many different metrics is an indication that humans created this, and there's so many different angles to look at it. Okay, questions?
Now, this is, since if anybody has a question, please interrupt me, because the questions is more priority. But this is raised something in my mind, and maybe we can also have similar discussion next week, Tom, about the following, which is when you are able to accept the classification as a base to a regression task. Now, this is, I know the question, it's look like understandable maybe somehow right now, but I will share a use case and find how the best way to model this use case, and either using classification, regression, or starting from classification and move to regression, or vice versa. And all of these metrics, how it's worked with us according to this kind of use case. I think it will be a nice session. And also I prefer if Jonathan can push us to prepare it, push me at least personally, So during the week, if we are able to make a call, Jonathan, I will show the use case and we can discuss about it. Maybe together we can, with Tom for sure, we can show it next week.
Okay.
Okay.
Yeah. And by the way, if any of you want to know how to create these videos, I was including both the code to do these are just Matplotlib plots. What I did was I created a lot of different images for different states and then stitched it together as a video. And if you look through my posting history, you will find all the code to do that. But y'all have a direct line to me too. So all you have to do is give me a direct message on Slack and let me know, Tom, please, I couldn't find that in your post history, or the indentations got messed up, which I wish that wouldn't happen on LinkedIn, but would you paste the code directly? And if enough people start asking, I can just put it in the tech chat code or the pipeline class chat, the tech chat channel or the pipeline class channel on our Slack. But we hope this helped. Now, it could be, I'm just trying to imagine, because I've been through all phases of being a student. I can remember my childhood vividly. This might have been overwhelmingly confusing. Don't let that worry you. Treat this as a first pass. It's like you've gone on a hike in this beautiful territory and it was too busy. There was too much beauty, and you're just going to have to hike it 5 more times before you can appreciate everything that's there.